Find the slope of the graph of an equation? I only know how to find the slope of a line if I'm given 2 points on the line. Hey, wait, that gives me an idea. I can just find points that are on this line by finding values of x and y that satisfy this equation. Keep track of them in a little table like this. If I put in x equals 0 over here, we'll get y is 0 minus 3. That gives me negative 3. That tells me at the point 0, negative 3 is on the line. Now if I put in x equals 1, I'll get y is 2 minus 3. That's negative 1. It tells me at the point 1, minus 1 is on the line. Now if I put in x equals 2, 2 times 2 is 4, minus 3, that gives me 1. So the point 2, 1 is on the line. Now I have a pretty good idea where this line is. Looks like this line is right here. Also have a pretty good idea what the slope is. Use the rise over run thing. We go up 2 and to the right 1. 2 over 1. We think the slope is 2. We can check that out using a couple of these points here. Got these 2 points on the line. We know how to find the slope of a line through 2 points. We take the difference in the y coordinates, divide by the difference in the x coordinates. 1 minus a negative 1 is 2. 2 minus 1 is 1. 2 divided by 1 is 2. Hey, wait a second. Look at that. There's a 2 right here. And the slope came out to be 2. Maybe that's just a coincidence, but it would be awesome if those two always came out to be the same, because then you could just look at this question and go, hey, there's the slope, it's 2. But how can we make sure this will always work out? And we can test that it'll always work out by replacing this 2 with a letter. I'm going to replace that minus 3 with a letter as well. I'm going to replace the 2 with the m, the minus 3 with the plus b. And back here we saw that this 2, that's what the slope came out to be. So we're going to find the slope here and see if it always comes out to be m. And we'll do that the same way we worked through the previous problem. We'll find some points that are on this line. We'll start with our x and y here. If I put in x equals 0, well then that'll go away and y will come out to be b. If I put in x equals 1, well then I'll just have m there, m plus b. Y will come out to be m plus b. And now I can find the slope of the line between these 2 points. Take the difference in the y coordinates divided by the difference in the x coordinates. M plus b minus b. That just leaves m. 1 minus 0 is 1. M divided by 1. Sure enough, the slope always comes out to be m. How awesome is that? This is always the slope. Now, of course, you might wonder, what's up with that b? What's so special about it? Well, take a look at this point here. We saw that the point 0b is always on the graph. Well, if the x-coordinate is 0, then the point's going to be right here. It's going to be somewhere on the y-axis. B tells us where the line hits the y-axis. This has a special name. This is called the y-intercept. And we can see an example of this in action right back here. Our line hits the y-axis at the point 0, negative 3. And there's the minus 3. So that's what the B tells us. It tells us where this line is going to hit the y-axis. And some people will use the term y-intercept to mean the point. Some will just mean the value b. I don't care which you use as long as you're clear which one you're using. And because this form of an equation so quickly tells us the slope and the y-intercept, we give it the very clever name of the slope-intercept form. Because you can just glance at this and see the slope is m and the line goes through the point 0b. Hey, that gives me an idea. Imagine we started off with this. We just started off the intercept 0b and the slope is m. We started from there and we used that point slope thing that other guy showed us. That thing is pretty slick. So I want to give it a try here. Line goes through 0b and has slope m. What happens if we jam this into that point slope form? Well, we got the difference of the y-coordinates equals the slope times the difference in the x-coordinate, x minus 0. That's the point slope thing that other guy was talking about. And we'll get y minus b equals, well, this is just m times x. I'm going to add b to both sides. And out pops the slope-intercept form. That's pretty slick, so we can see that these two are very deeply related. All right, now that we have a good handle on the slope-intercept form, let's tackle a couple problems. We'll start right here. We're going to find the slope of the graph of this equation. We got our shortcut now. Right back here, right? We get the x thing over by itself and we say, bam, there's the slope. So that's what I'm going to do right here. I'm going to subtract this 2x over there, and I'm going to have 9y equals minus 2x plus 9. Bam! See the slope, see the intercept. Looks like the slope is minus 2, and the y-intercept will be the 0.09. Let's check this out. Let's go ahead and, I'm going to go ahead and plot the line. Make sure we're doing okay here. Now if I put in x equals 0, I can put it in there, I can put it in up there, I'm going to see immediately that y is 1. So 0, 1. Wait a second. I thought this thing was supposed to tell me the y-intercept. That says 9. But it's 0, 1 that works here. What's going on? Look back here. Let's see. y equals mx plus b. Y equals mx plus b. Y equals, I got to get the y by itself. I've got to divide out this 9. That's the key here in slope-intercept form. We're solving for y. Y's got to be all by itself. The coefficient has to be 1. I can't have a 9 sitting there. I've got to divide out this 9 here. And divide both sides by 9. I'm going to get y equals negative 2/9 x plus 1. Now we see, there it is. There's our y-intercept right there. I can go ahead and stick in another point. What do I want to put in here? I don't want to put in x. Put in x equal, if I put in x equals 1, I'll get y is 7/9. If I put in x is 2, I'm going to get y is 5/9. And on and on and on. I'm going to get a line that looks kind of like this. It's not the prettiest picture, but we can see that the slope is negative, and we can see that it's pretty close to 0. The slope is going to be real close to 0, and we can see from our slope-intercept form that the slope is indeed negative 2/9. All right, one more problem. We've got 2 points here, x-intercept. Well, the y-intercept is where a line hits the y-axis. The x-intercept, yeah, that's where the line hits the x-axis. All right, we can go ahead and plot this. X-intercept there, y-intercept there. We can see this is our line. Goes through these 2 points. And, well, I could go ahead and find the slope using these 2 points, but we can see the slope right here. Up 4 to the right 3. We can see right away that our slope is 4/3. Now I could break out that point slope thing, that whizzy thing that other guy was showing you, but if you've got the y-intercept already, you don't even have to do that. This is where slope-intercept form can be really handy. If you've already got the intercept, you can just drop the slope and the intercept right into it. Put my slope in here for m, put the y-coordinate of the y-intercept in here for b, and I get y is 4/3 x plus 4, and we are done. Thank you.